is important in this question? It is a little physicsy because surprisingly there's math and physics. I know, it's crazy. Give me the general idea. What's it about? Boat, that is, doing what? Moving. Okay, what do we need to know here? What's the really important stuff?
100 kilometers east and then 50 kilometers.
Do I care it's a boat, it's a car, it's a bicycle, it's a person walking? Don't care. All I care is really the directions and the measurement. What else do I want to care about? Awesome. More specifically, because there could be a bunch of angles. Do you kind of remember these from last year? Yeah. Okay, so we would have started with a diagram. What would we have put first?
An arrow going.
Put a triangle.
Well, we can't jump to the triangle right away. I need either the boat, the port, or something else. So I need a reference point. So what is the not moving piece? It's the port. What direction is the boat moving first? Is that left or right? That was the weirdest arrowhead ever. I don't know what happened there. Got excited. Then it turns and it starts going up. And just a reminder, none of the triangles or diagrams we ever draw are to scale, so I didn't measure those out and know that it's exactly half of the first measurement. It's just a rough diagram. And then they need to form some kind of triangle. So the first thing is shortest distance. How do we find shortest distance between anything?
Hypotenuse.
Yes, but with the shortest distance, it's always a... don't say straight line. That drives me crazy. What's a not straight line? It's just a line. A line. Shortest distance is always a line. A not straight line is a curve.
That's a curved line.
No, it's a curve. And so the formula to do part A, or the first part of the question, was actually way back from grade 8. Anyone remember it? A squared plus B squared. That was grade 8.
Pay attention to
I know. What formula? What's it called? Okay, I'm going to pause. What do you know about C in this formula? It's the hypotenuse, which has to be the... How do you know which side is the hypotenuse in a right angle triangle? So little right angle, opposite the right angle is always the hypotenuse. Does it matter which is A or B? Nope. So I'm going to put 50 for A for no reason, 100 for B for no reason, and I'm just going to put an H just so we know it's the hypotenuse. And then it's a straight up bed mass, so we do the squareds first. What's 50 squared? That sounded like a question mark at the end. I should give you like magical calculating machines and then put them right in front of you. And what's 100 squared? And then we add those together. Don't use your calculator for that, please. And then how do you get rid of a square? This was like in grade 8, was like the biggest thing you had to learn, like squareds and square roots. And then remember, I came along grade 11 and was like, but wait, every time you put a square root into an equation, what do you have to put in front of it? And so get me the decimal value on your calc. Ooh, that was quick. Someone just confirm 111.8. And then what happened to that plus minus thing? So why didn't that matter in grade 8? It's a distance, so we reject the extraneous root. Do you remember that notation or wording from before? So we take just the positive because it's a distance. Shortest root, 111.8. Does that put grade 8 back in your hand? Okay, how do you find the angle from the port to the boat? So is that the bottom angle or the top angle? The bottom to the top because of the port to the boat. So the bottom of that arrow pointing up. So then grade 10, we were like, ooh, you are ready for SOHCAHTOA. And tell me what you remember about SOHCAHTOA. So tan is O over A, opposite over adjacent. Sine would be Opposite over hypotenuse. Cos would be? Adjacent over hypotenuse. And so we have to name these sides before we can do anything else. So opposite the angle, because we are not creative, very obvious people, we call? And then the 100 we would call? What does adjacent mean? Just in the English language, what does it mean if you're adjacent to someone? Attached or next to them. So we say this is the one that's next to the angle. That's where it comes from. That will come in grade 12. And it's fascinating. Can't even talk about it yet. And there's actually 3 others you don't have even met yet. There's 6 different trig functions. Shh. Shh. Look at the blue sheet. No, don't. It'll scare you. Don't look at the blue sheets. Don't do it. It will scare you. And then we use tan. And then we sub in what we know. We said O was 50, and A was 100. And then I have to get rid of tan because I want this angle by itself. So what's the opposite of tan? Inverse tan. So that's why we inverse tan both sides. So an inverse tan and a tan cancel, which leaves us theta. And then in our calc, we go second function tan, 50 divided by 100 equals. Let's go to, 1 decimal place. That's routed correctly, 26.6. Because we have O and we have A. They were the 2 given ones in the question. And so that's when we look at SOHCAHTOA and we look what has O and what has A. You're going to know if you're in the wrong mode because if you're in radian measurement, radian is a really small system of measurement. I'll give you, you don't need to know this, but 90 degrees in rads is 1.57. So 90 equals 1.5, like it's a teeny tiny measure. So if you're getting like a really small number, like this would be about 0.4, that's going to tell you you're in the wrong system. You're going to know the minute you get your first answer because 0.4 in an angle is how much? Like so teeny tiny you can't even measure it. That's how you're going to know if you're in the wrong angle. There's everything you did in grade 10. Back in your head. I'm going to take the same question and I'm going to phrase it like a mathematician. Because it's not generally the mathematicians that care about boats and angles, and you probably did trees and things falling out of trees or ladders leaning against houses. That's scientists and engineers. We don't care about that. We care about the math behind stuff. So I'm going to give you just a point on a coordinate grid. And I'm going to tell you the coordinates of that point, which I'm going to call P, are 100 and 50. And I'm going to join that point back to the origin using a line segment. And I'm going to put an H on that line segment. And sometimes we call it R, which I'll tell you why in a second. So we use H and R just interchangeably with each other. And I'm going to put my little theta symbol in between the x-axis and that line. Let's talk about this Greek letter. It is theta, and I like to spell it because it's not feta like the cheese, like number line. It's not number lion. It's not feta, that's cheese. It's a Greek letter. Why do we use Greek? Because of Pythagoras, just to pay homage to the Greeks who invented it. This is the equivalent to what English letter? Equivalent to what English letter? You think it's O, but it's not. It's T. And if you think kind of a scripty T, we kind of write it like that. And that kind of comes from the fact it used to be a full circle. That's where theta is coming from. Just giving you this diagram is asking you exactly what that last example just asked you. There's no words. There's nothing else. That's asking you the exact same question. So just flip back and read about the boat and the port again. And read all that stuff that's in there and all those words that are in there. And you need to be able to understand the English language to understand that question. Do you need to understand English to understand this? That's what math generally does. It takes language out of things. This asks you the exact same thing as what the other question just asked. How? Well, it's implied that there is a little triangle here. If I draw that perpendicular side, I'm just doing it imaginary. Because I've given you the point, that's given you the x-coordinate, which is the distance along the x-axis. And it's given you the y distance, or distance along the y-axis. And when variables are just plunked down, it's assumed you have to do what? Solve for them. So this is asking everything the last question just asked without all the language and without all the crap about the port and the boat and the directions and everything else. How cool is that? Little glimpse into next year. You don't need to know this part. The reason we call this R is because I could, in theory, swing this point around and make a complete circle. Let's just pretend I actually kind of drew a circle there. I could swing this point around and make a circle. And what do you call the distance from the center of a circle to a point on the outside? It's called the radius. That's why we call it R. And this is where what's going next year when I said it's really actually not triangles, it's circles. That's kind of why that idea is going to be there. Just plant that idea. We're going to talk about angles in standard form. Circleometry, I like that. This is one of my favorite questions I'm going to ask you all year. So I'm going to ask you the question, then I'm going to give you a couple minutes to just chat with someone about it. I love this question because there's usually blank stares. What is an angle? What is the definition of an angle? Turn and talk. Figure out a And so let's just draw any kind of angle. I'm going to make it an acute angle. What does acute mean? Less than 90. What does bigger than 90 mean? Obtuse. Put my theta in there. And I'm going to put just an arrow to indicate the direction. And what we're going to add in for this year is if the direction is not indicated, we assume it's counterclockwise. Okay, so assume counterclockwise. If you don't like the notation, CCW, write it out, counterclockwise. Which you'll learn next year when something goes clockwise is actually a negative angle. Kind of cool.
If it was going, oh, you said counter.
And so because of the direction, the bottom would be the initial side, and the other side would be terminal side. Does that definition make sense? I like the word rotation in there because it really gives you an idea of something rotating and moving and creating the angle. So standard position is a new definition for you. For an angle to be said to be in standard position, the initial arm must be on the x-axis. The initial side or initial arm must be on the x-axis. And the vertex is a word you may not remember way back from grade 7. That's the vertex of an angle, so the pointy part. Where those two lines or sides meet up is called the vertex. And the vertex must be at the origin. That's called an angle in standard position. Or initial arm on the x-axis, vertex on the origin. If you go back up here, what I drew for you and you didn't know was an angle in standard position. So the starting line was on the x-axis and the vertex was at the origin. And it went counterclockwise. So an example of an angle in standard position. I'm going to go into Q2 just for fun. And the reason we need something called standard position is because when I just draw a line like that on the coordinate plane, there's actually two angles that are formed. There's counterclockwise and clockwise. And then are we going from the y-axis? Are we going from the negative x-axis? So we have to assume a standard position, which means this starts at the x-axis and goes counterclockwise. And so our theta would be this angle in here, which would be bigger than 90 in this case. It's not the one that's tucked in between the negative x-axis that's less than 90. So the purpose is just so when I draw a line, we're all talking about the exact same angle. I'm going to use the exact same line, so back in Q2. And if I were to draw this angle in here, that is not standard position. Why?
Since it's not going counterclockwise.
It's not starting at the positive x-axis, and it's not going counterclockwise. It's an angle, and it's valid, and we could calculate it, but we have to have some kind of standard so that we're all finding the same angle whenever I say find an angle.
The definition should be put positive x-axis.
Yes. Yes, sorry, to me that's assumed. Are you still with me so far? Are you humoring me by saying that?
Is it thick because it's not double paved?
The sub didn't do it. Oh, I didn't even realize it was that thick. Yeah, it's not. It's lots of scrap paper for you. Keep in mind, this first part of the unit is theory. You're not going to see the why we're doing it, and that's okay. So just bear with me. Check this out. I'm going to go back to that kind of idea we did with the boat and the port, except I'm not going to put values this time. I'm going to call this P for point, and I'm just going to call the coordinates x and y, because I don't know specifically where they are. I don't care. It's just a general point anywhere on the coordinate plane. And I'm going to join it back to the origin so that I have a terminal side and an initial side. And I know in theory I get a triangle just by dropping that imaginary perpendicular side. And because we talk about angles in standard position, I know that it starts at the positive x-axis and rotates counterclockwise, so theta would be this guy in here. And I don't have values this time, but just because I've defined this as x and y, I know x is the distance along the x-axis, and y is the distance along the y-axis. And I can label this the hypotenuse, and I'm going to put in brackets r, because now you kind of know that we call it r sometimes for radius for that circle that's coming next year. And so I can create just a generic formula to find h, and it's just coming from the Pythagorean that we used before. So I can say h is the square root of x squared plus y squared, because y would be the opposite side, and x would be the adjacent side, and h would be the hypotenuse. And I can create three just little generic formulas for sine, cos, and tan. And sine I know is O over h, but I've defined O as y and h as h or r, whatever you want to call it. Again, I typically call it h this year, and it's going to switch to r next year. And cos is a over h, and I've defined the a side as x and h as h. And tan is O over a, but I've defined O as y and a as x. And then I want you to put these in a nice highlighter box, and I'll tell you in a second why we need to know them. And now you're going to grab some paper and write angles in standard position on the top of your paper. I would call it angles in standard position. Those are cute shorts. I like those. What? 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 And so here's a typical grade 11 trig question. The boats and the ports and stuff is gone. They're just saying a point Force 7 is on the terminal arm of an angle in standard position. Standard position is just telling you that we know it's on that positive x-axis. It's going in counterclockwise direction. We want to know the distance from the origin to P. We want to know the 3 trig values, and then we want to know what's the angle of that value. So we don't normally draw a diagram, but I'm going to do it for the first one just for the visual people so you know what we're trying to find here. And so they told us it's 4 units to the right and 7 units up. They told you right in the question that P lies on the terminal side, so they're saying join that to the origin. And because it's in standard position, we get this little triangle when we drop that imaginary perpendicular side, and we get a theta tucked between the x-axis and that terminal side. And so from the point, we know the bottom of the triangle is 4, and the vertical side is 7, and the other side is h, which we don't know yet. And so part A wants to know what's the distance from the origin to P. Well, what did I just label that? So these formulas are just to be able to do trig with just a point value and not have to have a triangle and not have to have a diagram. So we can jump straight to h equals the square root of x squared plus y squared. And just by looking at the point in the question, what's the x coordinate we were given? 4. And what's the y coordinate we were given? So it's just Pythagorean theory. We've just renamed it so you can just plug in the xy coordinate of a point. These would typically be non-calculator questions. 4 squared? 7 squared? Add them together. But wait, unit 2. We did a whole unit on radicals. Do you remember simplifying radicals? And adding and subtracting and rationalizing? How do we simplify radicals? Do magical math stuff, yes. Factor tree, right, we're looking. So we have to see, can we simplify 65? So if you don't know offhand, then just do a factor tree. There's definitely a 5 in there. Yeah, 13. Both of those are prime, so what does this tell us? We can't simplify, it's root 65. So just make yourself a note, simplify if possible. Point something something. So it is irrational, not rational. B asks for the 3 trig ratios. That just means the fractions for sine, cos, and tan. These are called the 3 trig ratios. And then you'll meet the other 3 next year.
Do we have to put plus or minus in front of this?
It's a distant, so we assume that it's positive.
So 65.
And so these new, and I'm going to put new in quotation marks, formulas, again, are the regular formulas. It's just allowing you to use the point value without having to think about the triangle and the sides. So we know that sine is the y coordinate over the hypotenuse. Just from the point, what's the y coordinate? 7, we just calculated what's the hypotenuse, root 65. That's all. That's what they want. The ratio is just the fraction. Cos is x over the hypotenuse, so the x from the point is 4. Hypotenuse we just found is root 65. And tan is the y coordinate over the x coordinate. The y coordinate is, and the x coordinate is 4. Do we have to rationalize? Not in trig. I'll tell you why in a second. It's kind of nice we don't have to rationalize. Yay! Question so far on what B is asking you for. 3 trig ratios. That's what it means is the fractions. Part C is now just to finish off the question, so it would be the same as find the angle from the port to the boat. Same thing, just without all the context. Grab any one of these. It's completely up to you and solve for theta. Do you want to use sine? Do you want to use cos? Do you want to use tan? Tan in this one was the smartest one to choose. Why? Not just that. There's another reason tan's the smartest one to choose. Because it's given. So if you had made a mistake in A and you had picked sine or cos, you'd have a continued mistake. So these are given values. How do you solve for theta? How do you get rid of tan? What's the opposite of tan? Inverse tan. And let's go to 1 decimal point. Sorry? 60.3. So we have tan of theta, and we want to get theta by itself. So theta is like x, it's just a variable, right? So if there is a coefficient, we divide. If we're subtracting, we always do the opposite. What's the opposite of tan? Inverse tan. It's the only way to cancel it out. If you're finding an angle, you use an inverse. Yeah. There's a grade 11 question. That's what it's going to. It's going to give you a point. Say, find some stuff. Example number 2, we're going to do the exact same thing, just a different point. And generally I said we don't draw the diagram for these because it didn't really help us in answering the question, so I'll do this one without. All we really need to know is that 3 is the x coordinate and 4 is the y coordinate. And how do I know the first one is x and the second one is y? It's alphabetic, so x comes before y. We know we're going to need the hypotenuse, so we can just grab either Pythagorean theorem or the formula that I just gave you. It's going to be 3 squared plus 4 squared. 3 squared, 4 squared, 9 plus 16, square root of 25. Ooh. That's kind of cool, 3, 4, 5. Grab your red pen. Teacher may have told you last year, may not have. They're a thing called Pythagorean triples. Pythagorean triples are a set of 3 numbers that when you put into Pythagorean formula, they are all whole numbers. So it means you don't get that nasty square root like the last question. So 3, 4, 5 is the smallest Pythagorean triple. If you know the x and y are 3 and 4, you can say right away the hypotenuse is 5. You don't need to do any work. It's assumed 3, 4, 5. What are some other Pythagorean triples you might remember from last year? 6, 8, 10 is a second Pythagorean triple. You don't? Oh, yes, you did. Oh, yes. Oh, yes, you did. Yes, I guarantee you did. I don't know any of the other you, but I know you did. I know you did too. Oh, yes, you did. Yes, you did. Yes, you did. Give me, there's another one that comes up a lot. Five, 12. There is no pattern. I know. Pythagoras. We stoned him. It's all good. 5, 12. Guess. 13. Those are the 3 that are going to come up the most often in grade 11. I'm going to add the grade 12 one just so you've seen it. 7, 24, 25. There are, well, we think, we don't know. There are an infinite amount of Pythagorean triples. We actually don't know yet. And there are mathematicians in the world, their job every day is to find bigger and bigger Pythagorean triples. Because we don't know yet, are they infinite? Is there a pattern? Do they mean something? We don't know. We don't know. You can check it out, do the squares and see what happens. So that's mathematicians. Their job is just to find more and more Pythagorean triples. You don't have to care about Pythagorean triples. You do not have to memorize these. You do not have to use them. What it does, though, is makes, number one, the question easier, and it can turn a calc question into a non-calculator question. So if I gave you 7 and 24 and said, find the hypotenuse, you've got to figure out 24 squared, then add it to 7 squared, then try to figure out the square root without your calculator. If you memorize this and I give you 7 and 24, what do you know the hypotenuse is right away? It has to be 25. It's completely up to you. I would, because it makes the question way easier, and they're going to come back next year. Why are you danging when it's way less work? Way less work. Again, no, but do you want to do 24 times 24 without a calculator? If you want to, great! And then figure out how to take the square root of it without a calculator.
So it goes, so the 3, 4, 5, 5 is the hypotenuse?
Always the biggest one is the hypotenuse, the longest one. Okay, so that was part A. Part B is the three fractions. No, not theta, sine theta. That just looks wrong. Sine theta equals. Psi is y over h. Y is. H is. Cos is x over h. X is. H is. Tan is y over x. Y is. X is. You're the first one to notice. Yeah, I cleaned it off today. Yeah, no, you're right. You're the first one to notice. I'm starting to pack. Sorry. Things are going to slowly come down, go into boxes. I know. I know. You need to find an angle. Pick any one of the three. It's completely up to you. Which is the smartest one to pick is tan, because if you made a mistake in part A, you're going to make a mistake here. We're trying to solve for theta. How do we get rid of a tan? What's the opposite of tan? Inverse tan. $53. Can we go to one decimal place? Confirmed. So we're not asking you really anything new from last year. We're just phrasing it differently. So last year would have been the ladder leans against the wall, the foot is, remember all those stupid questions. Same thing, it's just more mathy this time. Let's look at number 3. Again, it's not asking you anything new, it's just looking weird because it's completely different than what you've seen before. If sine theta is 5 on 12, determine cos, tan, and theta. That's what they've given us, something they want us to magically come up with cos and tan, and then theta, just from that kind of stuff. Well, theta is actually the easiest one to do, so I would probably do it first. How do you get rid of sine? Inverse sine. So we can do theta right away, so inverse sine this on our calculator. I'll just write down what we're doing. And it says nearest angle, so no decimal places. I heard 25. Confirm. How do we get the other two fractions? Well, all we're going to do is go back to our triangle. Now, you can think of the new formulas with x and h, or you can go back to your SOHCAHTOA. It's up to you. I go back to SOHCAHTOA, and I write that at the top of my paper because I'm visual. What do you know about sine? What are the two sides of the triangle that it gives you? O and h. What do we need for cos? A and h. And what do we need for tan? O and a. What do I not have? So I need to find a. Well, how am I going to find it? Pythagorean theorem. So I know that o squared plus a squared equals h squared. Or I can say x plus y squared equals h squared. It's completely up to you which way your brain wants to think about it. Whoa, what? Why whoa?
Can you just explain that really?
This or this?
That part.
This is just Pythagorean theorem right angle triangle. So these are the two sides, and I'm about to plug them in. This is a squared plus b squared is c squared.
But with
Opposite, adjacent, hypotenuse.
okay,
We're okay where this came from?
why that was so hard for me.
Again, if you'd rather use the one we just used, it's the same formula. It's the exact same. It's whatever way your brain wants to see it. O is 5. A we don't know yet. H is 12. 5 squared. And I realize I kind of crammed this in here. A squared, don't know. 12 squared. How do I get the 8 squared by itself? What do I do with that 25? Subtract it. Offer of 119. Sorry, I'm writing it so squishy. I should have left my room. Confirm 119?
Yes.
So therefore, A has to equal? Are we doing okay there? It is prime. Again, because these are distances on a triangle, we just ignore the negative for all of them. Is it still okay? Well, now I can fill it in. What's A? Root 119. What's H? Done. Go to tan. What's O? What's A? Done. We don't rationalize because what we would do with this is find an angle, so it doesn't matter if it's rationalized or not. If you want to, great. If you don't, who cares? Questions so far? I'm not adding new math, but I know I'm adding a lot of new notation and formulas and changing what things look like. Number 4. This time they're going to give us cos. Step number 1, label the given formula. What 2 sides did they give us by giving us cos?
Adjacent and hypotenuse.
Find the third one, because we're always going to need all 3 sides. So I know that O squared plus A squared is H squared. Or X and Y, or A, B, and C. Whatever your brain likes better, it's all the same formula. O squared I don't know. I'm going to do the squareds in the same step. So if I put 3 in and squared, I'm going to get. And if I put 7 in and squared, I'm going to get. That means O squared is. And O is. And can we simplify that one? Yep. What times what? And so root of 4 times root of 10 becomes 2 root 10. I'm feeling like you don't remember that from Unit 2.
Because then you move down the 4 and you turn it into
2 squared and got it. Okay, what are the 2 sides that I need to do sine? O and? What's O? What's H? What are the 2 sides I need to do tan? Yeah, or what A, either one. What's O? What's A? Find theta, pick any one you want. What's the easiest and best one to pick? Cos, because then if you made a mistake with sine or tan, you're going to make a mistake here. How do we get theta by itself? How do we get rid of cos? Inverse cos, nearest degree.
64,
Questions so far? Five is a wackadoodle question that until you've seen one, you have no idea what it's even asking you, and there's one like that in the homework. That's why I threw one in. So just read to read and then not understand it.
Oh, it's like the opposite.
one more, come on, stay with me, one more. Hayden, stay with me. I know. He usually is by 11:03, you know. Nice. And what did I keep saying? If you're getting random tiny numbers. I was like, everybody press your mode button. What should be black? Okay, I take it back. He was gone by 10:59. 10:59. Did you hear about Pythagoras being stoned? Good, 10:59. You were still with me. Example number 5 is kind of a backwards thing. So I'm doing a just diagram for the visual peep. They've told us that the angle is 20. I estimated 20-ish. What else do we know? 8. What in this is 8? What does the 8 refer to? H. So they told us that's the origin to that point. We don't know what the coordinates are of P. Find the coordinates of P. So go back to here. Do I have a formula that might take care of x and y? Okay, the problem with this one is I don't have both of them, so I can't use tan. I'm going to start with cos. Why? Because I like it. What do I know in there and what do I not know? I know theta. I know h. What would h be? What am I trying to solve for? Okay. How do we get x by itself? What's the opposite of dividing something by 8? Now what? Yeah, this is a straight up calc question. Hayden, could you make sure your mode is on degrees? Okay. That sounds confirmed? Okay, so we know the x coordinate. We know it's 7.5 units to the right. What do we not know? Y. Okay, is there a formula maybe we could do with y? Ooh, sine. Tell me about sine.
Sine of 20 equals L over 18 y.
That's an 8, but I started to write a 2, but it's an 8. I was thinking 20 in my head. Let's say I'm dividing something by 8. How do we get rid of it? Offer of 2.7. And so now let's just state P. What would P be? 7.5, 2.7. Does the working backwards make sense?